Hello, everyone. I'm going to quickly go over the notes for finding an epicenter. All right. The way we find an epicenter is through a process called triangulation. For these notes, it says one station. Station is just a seismograph. So when I say one station, I just mean the information from one seismograph, one location. All right, so one station can only tell you the distance to an earthquake, distance to the epicenter. Can't tell you the direction. The only piece of information that one station can give you, that one seismograph can give you, is the distance to the epicenter. In order to find the epicenter of an earthquake, you need at least, at minimum, 3 stations. I mean, you could have 300, you could have 3,000, but you need at least 3. 2 won't do it. You have to have 3. All right. Let me skip over those. Well, I guess it's all right. So, quick example. Here we are, school. If I told you that there was $10 million in gold 15 miles from school, somewhere on that line. We don't know where. I told you that it was also 20 miles from Lebanon. Those 2 points. It could be at one of those 2 points. Give you another piece of information, 10 miles from downtown. Now we see that that's where the gold will be located. When we're trying to find the epicenter, one of the main things we're concerned with is the lapse time. So the lapse time is the period of time from when the period of time when the first P wave arrives until the first S wave arrives. That's the lapse time. So, the earthquake happens, time starts going, P wave arrives, then the S wave. So that time between the P wave and the S wave, that's the lapse time. All right, so that's these graphs, P wave graph, S wave graph. And you can find the lapse time on this pretty easily. I've simplified that and I just did a graph here of the lapse time itself. So if you have a time, then you can convert that into a distance. So if you have a time, say, of 5 minutes, let's do 4 minutes. You just take that over until it intersects with the graph line. Take that down, and then that gives you a distance of about 2,000 kilometers. So it's just a matter of finding the time, going over until it finds the line straight down. So so here we have 3 seismograms. So here would be that would be the first P wave. That would be the first S wave. So we have 1 minute, 2 minute, 3 minute, 4 minute, 5 minutes. 5. So first P wave, first S wave. 1, 2, 3, 4, 5, 6, 7. 7 minutes. First P wave, first S wave. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.5 minutes. All right, so 5 minutes, 7 minutes, 10.5 minutes. All right, so if we go back to this graph, so 5 minutes from here, 5 minutes over there, down, that's about 3,400 kilometers. 7 minutes up here, over, down, about 5,300 kilometers or so. So, first station, it's just a distance. Then second station gives you more information. So now we have 2 points that could be the possible epicenter. Third station shows us where the epicenter is. So again, triangulation, you have to have 3 points or 3 pieces of information. And then the lapse time is what we're most concerned with in order to find out that distance. Take care. Have a good weekend.